story ever told.
Hello everyone, I'm Radu. I'm going to be your host today, and I'm delighted to welcome you on my first podcast ever, first episode ever recorded, Swift Nuggets. We're going to see what's new in Swift, basically. We're going to take a look over the Swift evolution repository and see what's coming to us. I'm glad that Swift 6.1 has just been included in the new beta version of Xcode 16.3. It just dropped a few days ago and is part of that Xcode. And we can try out a few proposals that got in the Swift compiler and Swift language itself. Excuse me, I'm speaking a bit with my nose because I am having a small cold. I hope this won't be a problem, but I will do my best to speak loudly and clear. All right. This podcast is also recorded and available on multiple platforms such as Apple Podcast, also YouTube if you want to see the video where I can walk you through the proposals and everything there. And yeah, let's start. So if you are curious to find out what's planned in Swift language, I'm not sure, but most of you know that Swift is open source, is available on GitHub, so you can contribute, you can check out and play your part in this modern programming language. And there's also a separate repository where you can see different proposals. You can see big list of documents that can be seen here, which propose different changes into the language. This helped like Swift got mature and mature. We got ABI stability. And now with Swift 6 and future is the focus will be on concurrency and make our lives easier to adopt this new way, protect us against race conditions and all that multi-threading complexity. Okay, all right, so Swift 6.1 has been announced somewhere last year in October, and it got a few changes. I'd say not that big changes, but still we have a few changes. It's not like if you go to the repository and take a look, there is like a couple of Swift proposals that got in, such as TaskGroups can now be created without explicitly specifying their child task. To remove the task and the parameter that you place there, the type of that parameter, so it's automatically inferred by the compiler. It's in Swift Evolution Proposal 442. And also they are saying something about the member import visibility. But the Swift evolution process has its own process. It's documented in the repository. But I want to tell you about three things that are important when you start working on a proposal, or if you want to find something new you'd like to add. You can do it in three ways. Like there are three kinds of proposal types, let's say. We have a proposal, which is very granular. You're like affecting a small change in the language, and you create your markdown and place it in the repository for PR, for request, and so on. The second one is roadmap, which is something bigger. You're introducing a complex change, which you'll break in separate proposals. It's not like one and that's it. You like create different proposals for that evolution roadmap. And finally, there's a thing called vision, which is something very broad, high level. You like, for example, I want to introduce concurrency in Swift 6, and that could be a vision. And you start working on that vision, like multiple roadmaps, and then you split them into different proposals. Anyhow, in this year, there was a communication, a forum message in Swift forums saying what's the plan for Swift 6 and the evolution after the Swift 6 has came out. And while we have this cool stuff about Swift concurrency, and I really like what the engineers at did that, and like open source community contributed to this. It's very nice. However, it's very hard to adopt it. Like I have tiny apps, but they are like on App Store, and it was very difficult to adopt the strict compilation flags on them. Anyway, so they heard the voice of the community. I'm not just the only one who faced those errors, and the steering group of Swift placed a vision for it, where they want Swift concurrency to be easier to adopt, and that's quite nice. They have one bullet point dedicated for that. Another one is to focus more on interoperability, especially with C++ and Java. And there was like group that is handling this part. And I like the idea. Like this is a new exciting world where we can use Swift and work with Java. Right. So this is the steer group. They focus on three things: make Swift concurrency easier to approach and adopt, provide powerful low-level language and library tools for high-performance programming and constrained environments, and finally, we improve interoperability with C++ and Java. Nice, but while the first and the third bullet points are pretty clear, like, hey, I want Swift concurrency to be easier to adopt, and I want Swift to work better with C++ and Java, the second one doesn't mean much. Like, powerful low-level language. I thought it was. Like, point refers to a new way of handling memory, like introducing span types, and this helps us have a more powerful language. And I think Swift will be even faster than we had, which is quite nice. All right, so what's new in Swift 6.1? There are pretty cool stuff, and I will show you like 5 or 6 of them, maybe more, if we have energy. I would like to start with this new addition to Swift packages called package traits, and it's part of the Swift proposal 450. And we have a new mechanism for SPMs to handle configurable compilation and optional dependencies within packages. Well, very cool indeed. We would like to have something like pluggable dependencies where like users can select between different implementations or modules based on their needs. We can also have something like platform specific code, include or exclude code depending on the target platform or environment. So we have some kind of settings or parameters to SPMs, but we call them traits. It's a name that was adopted by the team, which I think they're quite catchy traits. Right, so these customizable settings can influence the build process, and you can create something like options, configurable options, or you can modify the behavior based on those settings. I'm having here a package, and if you imagine, I will have the package.swift file where you place the name of the package, you create your package, you add the products, the dependencies, and targets, basically, and also you specify the tools versions. This new thing, it will be a dedicated entry, which is a set of objects called traits. And here, I mean, I can use the array syntax to place them. And on the proposals, I have a few examples with full and bar. Full is like a string, and then bar is like a trait, which is like the new thing that was added here in Swift 6.1. And I have multiple ways to do that. I have the string literal, where I can place the configuration name there, or I can use .trait to create a new trait object, which is like a static allocation. And I can say the name, I can put a small description, and also have something like enable traits, where like we would like to enable those traits into our package, basically. Okay, so let's use the same example, trait.bar. And in the package description, all right, so you see it's a static function which creates this trait. Trait is implemented as a struct in the language itself. And there's also cool because you can place some conditions when traits are enabled, then you can place a condition syntax, which you can have some platform dependent dependencies based on that trait. And you can use like compiled impose like or surround with if and if that trait, where you can execute some parts of the code simply as you did with debug and so on. So you use this part with settings, and which is a nice solution. All right, another one I would say 439 trailing comma, allow trailing comma in comma separated list. This one is nice as well. If you remember, it was something introduced. I'm showing here, like when you have an array of elements and you have multiple elements, you can put the comma on the last element or you can omit it. What's nice if you put on the last row the comma after the element. So imagine you have an array of rank or players, player 1, player 2, player 3, whatever. And on the player 3 entry, you place a comma here at the end to separate the next element. Well, this code compiles just fine. It will get you an error. You can also omit it. But what's nice, if you want to copy the last row and create a new static value like a player 4, you won't have an error, like the comma is already added there because you copied. If I wouldn't have, then I'll have a compilation error saying expected comma separator. Well, this proposal has been extended to other types which were not permitted, like functions or parameters, also function argument lists, in tuple expressions, also generic argument lists or dictionary literals or array literals. A tuple with different like variables, and on the last element now you can say a comma there, and this code will work just fine. Also, if you have like a function and you have 1 or 2 parameters, whatever, I can say now like I can have like a first parameter input 1 and put a comma after the type of that parameter. So I have found my methods input the name of parameter, and then I can place a comma here and it will compile. It's fine. I don't see a major advantage or breakthrough in the language, but I think it was nice addition to the language itself. So the comma is attached to the last element, and you can have this new thing. Now it's to 6.1. Right. We spoke at the beginning about the memory import visibility, which is an important thing. It was added in 444 in these proposals, and this proposal is saying that whenever you have a name of the declaration in another module, is considered in scope. So you have a definition of scope, what's in scope or not. This was like an inconsistency in the Swift's import visibility rules between top-level declaration and member declarations. Or currently, member declaration before 6.1 could be visible through transitive imports, which means like imported it by other files, while top-level declarations require direct imports. And this can lead to unexpected name conflicts and ambiguous references. With this proposal, with member import visibility in 444, now a module is visible if it's directly imported in the file, or it's imported from the bridging header, or it's re-exported by a directly imported module, which is like a good way of handling things. Nice. Another new thing that came into Swift 6.1 is the String.Index bringing approval of printed descriptions, which adds some kind of a way of showing better what we have in the index, like start index and end index of strings. You would now like the string object itself will conform to custom debug string convertible, and you now have a way to show better what's inside it. It's nice here. Before, if you print, so you imagine you have a string and you do a print of that string, and it's not like UTF-08, you have like emojis or other characters there, and you'd see some rubbish things like raw bits. The start index would like default to something there. You have some weird characters or some number of bits that are being encoded there, and now you have a more natural way of looking at the debuggable output of a string. You'd see like if it's a UTF-8 or if it's an any. When you have this first is the index of the first position in the string, basically you'd see there. And how many bytes, like you already had that, but now it's like way better to visualize how many bytes that specific character takes. You know, like a character can take more than 1 byte, if it's not like UTF-8, right? And this improves the debug syntax when you do print over a start index or end index of the string. Now you'd see that way visualizing your indexes. They're not seeing index the raw bits. We're not seeing stuff like 0 and parentheses. You see any UTF-8 or whatever, which is nice. So you have the offsets better visualized with these proposals. What else? 443, it adds, it improves how you'd see warnings in your compiler, in the compiler. Before you have different ways of handling the warnings that your Xcode outputs. You have 3 ways. Like you could treat all warnings as errors. You'd silent the warnings, like disable everything, the emission of all warnings, or cancel the upgrade of warnings to errors, which is it's not that flexible. And with the proposal of 443, we now have added a group. We have in the language a group of handling the warnings. And this can be like deprecated. You include all deprecation related warnings. You can have availability deprecating, and this is more specific to add available deprecation warnings if you have in the API. And also, you can have something like concurrency, for example, and the errors will be something like part of that warning. So to conclude, this proposal introduces new compiler options that allows us developers to have fine-grained control over how specific warnings are handled by the compiler, whether they should be treated as warnings or as errors. So you have this notion as group. 442 introduces the type inferences for TaskGroups child task result type. The problem was like currently before 6.1, when you use a task group, you must explicitly specify the result type, even when it could be inferred from the context. So imagine you had something like let sum equals try await, and you have this with task group method, and here you'd say of type int.self, and inside the body would have group in, and here would execute inside the body. There's a group add task one. Say we're gonna try that. 2 group.add ask. So you don't need to specify this thing with task group of int.self. It's inferred by the compiler, so we can delete that. The program perfectly work without that. This gives us a few benefits, like you have a more concise code. It's not that verbose. And it's better consistent with the Swift type inference system, and you have boilerplate reducible code. Like you don't write that many code. 449, another concurrency related proposal, and this 449 proposal addresses a safety issue with global actor isolation in Swift. Currently, the code that's not explicitly marked as isolated, you can still make calls to global actor isolated functions, which could lead to data races. Yeah. And this behavior was initially allowed to ease adoption for global actors, but it poses, as I mentioned, some safety risks here. Right. So with this proposal, you're now required to make an explicit isolation to the global actor isolated functions from a non-isolated context. So you have this at non-isolated keyword, not at, but non-isolated keyword to explicitly mark when you want to make such calls. And this change will be gradually rolled out with compiler warnings first, then it will be error in future Swift versions. Right. So basically, in the current code, you use my global actor dot sum function without any kind of warnings, and with this new thing, you'll need to use non-isolated my global actor dot sum function. So you want your intent to be explicit. This change will help us prevent accidental data races and makes the code's concurrency behavior more explicit and safer. Nice. All right. So this is pretty much it, what I wanted to show you about Swift 6.1. But we also have a few proposals which are quite interesting, which will be implemented in the future Swift version. For example, this 448 regex loop behind assertions. You might know them from a different language. So you have two ways of loop behind assertions. You have like positive loop behind, where where it matches the numbers only if they come after a particular symbol, right? And a negative loop behind. This was not in Swift, and you'd have now a possibility to do that. It complements the look ahead assertions already and improve the pattern matches capabilities for text processing and so on. Alrighty, the next proposal, which is called row identifiers 451 or escape identifiers, is an interesting one. It proposes to add row identifiers to the Swift grammar. Those identifiers are like backtick delimited and can contain characters other than the current set of identifier allowed characters in the language. Basically, what this proposal says is to extend the capability of those backticks to include more than what we have right now. And it writes quite an interesting motivation where it's saying like we use identifiers that are limited to a specific set of characters defined by the Swift grammar. But this is not enough. The proposal says that we want more, to have a more strong escaping characters and include more stuff into them, basically. And one example is when we write a test using the new Swift testing framework. We usually have at test, and in the parentheses we explicit say a few words about the test. We provide a description and then use that annotation to the function, to the test itself. Well, if the user wants to provide a descriptive name for the test, they have to do it twice now. Once they provided that kind of description, but now we need to do the same thing for the function's name. And we would want or have something like backticks, or this proposal says like backticks can be used to eliminate the twice-ness or writing two times the same thing, mostly. And also we're having things like we have an example for colors where we could want to provide some kind of numeric cases, where there are some situations where the best name for a particular symbol is numeric or at least starts with a number. So if you have in an enum cases with an integer, that is not allowed right now. If I'm having something like a color enum, and here I would like to place case 50, case 20, like a hue or variant to that color, I'm not allowed. I need to provide some kind of a naming for those parameters, like underscore, prefixing, or variant 50, variants 100, and so on, which increases the number of words I'm using, but also is not very useful because why not create directly 50, 100, and so on. And in the proposal, you have like different examples as well. In one section, we also have the function where test functions could use row identifiers to describe their purpose clearly without redundancy. We have a test function, square returns, and we say what we return, and then we provide the method to assertion, expect in that case. And in our case, we can say 50 here or 20 with the escaped the backticks. Put that number in backticks. In the current Swift implementation, we are not allowed to do that. I mean, it's not allowing us to put numbers in backticks when we're using cases. But with this proposal, we would want to have that, plus other things, which, right, it's permitting, we might think more than enough, but in other languages, you have this capability with backticks to escape more stuff into it. So the key points are like, this would propose using Swift keywords as identifier when we escape with backticks. It will help us the interoperability with other languages, where if we want to communicate, you saw the thing with Java interoperability, it would be easier to do that with making more flexible to the backticks. And also, like, I don't see any strong reasons why we should not be allowed to do that in the future. Next proposal is about integer generic parameters. This proposal introduces the ability to use ints as generic parameters in Swift, allowing for compile time known integer values to be used in generic context. Well, Swift does not currently support fixed size or fixed capacity collection with inline storage. You would use with unsafe pointer to achieve that, which is not that Swift. It fixes the current limitation where you would use like fixed size arrays. What this proposal is showing me is that if I'm having some kind of a fixed size array, such as a vector, which has 3 dimensions, I know for sure it's a vector 3. Var x is a t generic, var I is also t, and var z is also t. So I have 3 things, and I want to use a subscript to take from an index, which is an int. I need to return the t. It's either x, y, and z. I need to write something like a switch over the index. In case it's 0, then return x. In case it's 1, then return y. If it's 2, return z. But also if it's not this, then fatal error, or do some kind of a -1. And also if I need to set those x, y, and z dimensions of the vector, I need to switch again to the index. And in case 0 x is new value, case 1, y, new value, case 2, z is equals new value. So I have a subscript here. In case it's a default, then it's out of bounds here. I'm passing something like this now. And this is not very type safe. I can put it as an optional and return here nil. And also, like, don't do anything. I need to unwrap here. I put -1 maybe, or 0. I don't know if it's an integer, but who knows. I need to make now these things optional, and I don't like that much this part. It's not that good, to be honest. So this proposal about integer generic parameters, now I can do some kind of a fixed capacity buffers, fixed capacity, where you can say fixed buffer, and you have start, and then you have to reference the storage, which is an array of type T generics, and I have a maximum capacity. Capacity is 10, let's say hardcoded. I do an init, storage equals right, but I might have an empty in it. And here I can say storage equals empty array. And if I want to add new things to this fixed buffer struct, I can say append and add the new element and check the storage. If the storage.count is less than the max capacity that I set, which is 10, as return false. I didn't append anything. Otherwise, put something in my storage, put the element, and for example. But with the new proposal, I can directly do this. I can say new proposal. I can say struct vector let count inside the name, and here is the element. And here I can say the implementation. And that's it. Don't need to do anything else. So this proposal is quite nice. You have here a few examples with the matrix and vector in the proposal itself, the document, where you can see the matrix has let columns inside of the brackets generic, where you put the parameters and say let columns and let rows, which are integers. Then you could define the matrix as a vector of columns and rows, of course. And in the call side, you'd use matrix in the brackets 4, 3, and you have a matrix 4 by 3, and you can say columns, and you get the fourth element for 3 and also rows, 3 rows. Nice. Moving on, we have this 453 proposal, which is inline array, a fixed size array, where it's more similar with that generic thing that we saw previously. It's in complementary with what we saw previously, and you would use this inline array, new top level type, inline array, to the standard library. This thing will be added, which is a fixed size contiguously inline allocated array. It will be stored on the stack, so it's very fast. You know the size of it, you store it there. You don't have to store it in the heap. You usually have, when you allocate an array and you add elements to it, it will double the size every time it hits the maximum. So if I have 4 elements and I'm adding the 5th element, it will copy everything into a new buffer of 8 elements. This is how usually is done. So inline arrays will have the possibility to be set right from the start, the size. I know we have array repeating elements, but this is not the case. We just allocate it and we store it in the stack, as I mentioned. And here you see like it's non-copyable, it stores potentially not copyable elements, and so on. It's type safe. This is very important. It has a fixed size with compile time size guarantees, which is quite nice, and has a being on the stack and saved on the stack, has an efficient way to copy and write, similar with structs. And so there's a few use cases. You can use it in graphics programming application, or whenever you want to use a fixed size buffer in your system programming, or even in low level programming where memory layout control is very important to your program. It's best suited for small arrays, and key thing is that it cannot change the size after you create. 446 introduces non-escapable types, and it's similar with non-copyable, but now you have tilde escapable, and it's a new thing added. And if you remember the non-escaping part from closures, where every closure was non-escapable, but if you want to make it escapable outside of your function, you'd use add escapable. In the design implementation, the escapable concept, we have a new protocol called escapable, which is part of the standard library, and it applies to everything in Swift, all current Swift types, except the non-escapable closures. It can be passed to arbitrary functions, global variables, or return. So it will we will have a new protocol in the standard library, which will implement or extend the non-copyable protocol, And in a concrete context, non-escapable indicates non-escapability, of course. Swift evolution proposals are saying that we would use the same approach as for non-copyable, and we have that tilde non-escapable to suppress the escapable conformance to owner type. It's not allowed to escape the local context. It cannot be assigned to binding in a larger scope, and it cannot be returned from the current scope. And we have in the proposal a few examples of when to use or not. The issue is that once a function parameter is marked as escaping, Swift allows it to be captured and stored like anywhere. You can escape that, even if the function does not actually need to store the closure. This can lead to some retain cycles where the closure captures self and restore that, or loss of compilation optimization because the compiler cannot guarantee the closure will execute. It's similar with copyable, non-copyable, actually. And these types will support lifetime dependency constraints. So we add more constraints to the types. See what's new in Swift from Paul Hudson, a great example here with Mission Impossible messages. We had, I think in 5.9, if I'm not mistaken, the non-copyable structs and enums introduction, that tilde non-copyable, which says like this type cannot be copied, and then we have a bunch of restrictions added to them, which makes the instance unique. And here you'd get an error if you're using. So I'm using here, I'm allocating a user which is non-copyable, and then I try to make a copy. It will work. And then if I do user, I print the property of that user, then I have an error for it because I cannot assign new user to user copy because it will cause the original new user value to be consumed. So this value doesn't exist anymore. It will be part of the user copy, and that's it. We cannot use it. What we can say about them is, in case we have some kind of a person which is marked as non-copyable, like here I'm using the name. If I'm using that person with something with that non-copyable part shown, and I try to put it in a different person, in a different variable by copying it. I can make person.name and if I'm doing a print person.name, I get a compilation error, person used after consuming it. Well, where I'm consuming it here in this line, I don't know where I am assigning to another variable, and that's how I'm using the copy thing. So it guarantees me this is unique and used only once. And interesting stuff, we have these consuming keywords which were added that marks. We can trick the behavior with a thing called borrow, where we can borrow the variable itself using the borrowing keyword here. So next proposal is strict memory safety checking. Optins is another memory introduction. And this proposal aims to make Swift's memory safety guaranteed and a bit more strict by removing the ability to opt out of memory safety checks in release builds. It's a thorough proposal. It speaks about the dimensions of memory safety. You can have 1, 2, 3, 5 dimensions here. So I have a lifetime safety. I am guaranteed that I can access something, a variable, first up. After its lifetime has ended, are like you're going to have an error if I'm doing that. Also, ensure a bound safety, crash or error in case I have an array which has a dimension and I'm trying to fetch something from an index which is out of bounds, I'll get a crash. Type safety, Swift, I have here in Swift like all accesses to a value use the type to which it was initialized or a type that is compatible with that type. For example, I cannot access a string as if it was an array. I cannot do. Violations of this property are called type confusions. I know I have an int. If I would treat that int as a string, I'd get an error. If I'm having a var text string and then I would print that text, I would get an error because I haven't allocated the variable. And finally, thread safety, and speaks about Swift 6 and the new concurrency model. All values are accessed concurrently in a manner that is synchronized. And main changes of this proposal are about the memory exclusivity checks, which will always be enabled. We won't have collection checks build setting, and we're going to have also that thing is in the release part. We're going to have consistent behavior between debug and release builds, and a better detection of memory safety violations. Span access 447, access to contiguous space. We have a new type in Swift called span, which is a generic, and it gives an abstraction for a container agnostic access to contiguous memory. Right. In the C family of programming languages, memory can be shared with any function by using a pointer. All right, if you remember the pointers in Swift, this is how it usually does. You have a zone of memory, and you pass that zone to memory to a different part of your program. A heap allocated array has a continuously stored name fields where a single stack allocated instance can all be accessed to a C pointer. So this proposal with spans wants to have the same behavior as C, and gives you this pointer to the zone of memory that you want to leave. It's split it into multiple proposals. It requires non-copyable, which is already there, borrowing and assuming, and also I think non-escaping. It's a requirement to implement the span part. Right, with span, we have a safe, efficient access to contiguous memory regions. We won't have to copy data when we create views. It's thread safe, and we have better performance for array operations, which makes Swift even faster than it is. About the API, I guess it will be a struct which has two variables, start and count. Non-copyable, non-escapable. This is the generic element, and also the struct, the span itself to be. It can be copyable, of course, because you can copy that zone of memory, but non-escapable. In particular, a subsequence of a collection is semantically a separate value from the instance it was derived from. In the case of span, subspan representing the subrange of its elements must have the same lifetime as the span. This makes it different from a collection. All right, so we have this new span struct. We have a bunch of variables, count is empty, indices, and we can use it in our code. And there's also row span. In addition to this span, it represents heterogeneously typed values in contiguous memory. The row span represents untyped initialized bytes. We have a zone of memory which has not been initialized yet. You have two loading operations, unsafe load and unsafe unalign. Anyways, you have to use them carefully to avoid lifetime issues. You must remember that the shared access to the memory is read-only, you cannot write there, and you have to maintain ownership of those semantics. I think this is a nice thing to add, and it will definitely make Swift even faster. Also high performance when it comes to computing. 456 is add span providing properties to standard library types. Okay, so we have span, now we need to make it work, and we have a different proposal to do that. It's a convenient way of providing properties to various Swift standard library types that manage the contiguous storage that I was talking about. We have two things, spans and mutating spans, and this will come to play as part of arrays and array slices. And it will provide safe access to the underlying memory without copying the actual variable as we have for iterator, for example. Maintain Swift's safety guarantees while offering low-level access to that part. And here we have detailed designs. Basically, it adds the span struct that we saw earlier to array, so in line arrays and so on. Moving outside of the memory part, we have a new proposal about Swift package managers, where we would have a new testable build setting. This introduces a new build setting in SPM to control the visibility of internal declarations for testing. Right, so it adds a new testable build setting whenever you would use the add testable import behavior. You have an explicit control over it, and you can configure it per target. You have a better separation between testing and production code. And finally, 459, and the last thing that I'm going to talk today, is about collections and the conformances to enumerated. This proposal aims to fix the lack of collection conformance of the sequence returned by enumerated, preventing it from being used in a context that requires a collection. Currently, you have enumerated sequence, which is a type that conforms to sequence, but not any of the collection problems. We have a sequence, but it's not a collection, so it aims to solve this problem. Adding these conformances was impossible before one proposal because it would break the ABI, application binary interface, while now we can do that. So after that proposal, we are now able to do that. Which is nice because Swift UI's list and for each views will be able to directly take an enumerated collection as their data. It has a more efficient implementation and better integration with Swift's collection protocols. More efficient, so better support. Everything is nice. Alright, guys, thank you so much for listening to this podcast. As I mentioned, you can see the video also on YouTube. I'll share all links here and the demo project that I like, small playground that I play here with Swift 6.1 changes. It will be shared on my repository and in the podcast. Have a lovely day and speak to you next time. Thank you so much.